Evening, guys. All right, so it is Wednesday night, and we are doing relations and functions. And we are going to be, this is kind of going back a little bit prior to what we've already done. But this is some important information as well, and this is also going to take us into a little bit of the graphing aspect of functions. Not a lot, but we are going to look at it a little bit, anyways. Um, so, we're talking about relations and functions, all right? And here's some more definitions. Some of these you've already seen. A relation is simply a set of ordered pairs. The domain is the set first coordinates, the x values. The range is the set of second coordinates, or the y values. This is the important one. This one, relation, input, and output, are the four important ones for this particular lesson. A function is a relation, so it's a set of ordered pairs that assign to each member of the domain exactly one member of the range. And in doing that, so basically, I guess you could say in simpler terms, for every x value, there is exactly one y value. And then you have the inputs, which are also, they're the members of the domain, and so you'd have to look back at domain. And also the outputs are the members of the range. So anyways, we will, now we're going to actually get into some examples, okay? So let me actually draw a couple lines just real quick so that this actually will make a little bit of sense. Okay, now I'm asking you, this relation, okay, is it a function? Well, in order for it to be a function, the first thing you need to determine, okay, so we said a function is that for every member of the domain, there's exactly one member as assigned to exactly one member of the range. So I have George, and the easiest way to do this then would be to take the domain and make sure, does it go to just one of the members in the range? And as you can tell here, it very clearly does, because George goes to 202, Carolina goes to 142, and Saul goes to 202. Okay? Now, this does not say, okay, it did not say that a function is something that for every member of the range, there's only one member of the domain. Okay? So these can go to more than one of these. But these cannot go to more than, but these can't go to, I actually said it wrong. These numbers here cannot go to more than one of these. So George cannot go to 202 and to 142. Carolina can't go to 202 and to 142. Okay? But 202 can go to George and to Saul. So basically what it is if the domain members repeat themselves, then it is not a function. Okay? So this is a function. Okay? And an easy way to tell is to write all the pairings. Give me all the relationships. And if you don't see an x value repeat, then you're okay. So the first pairing would be, the first pairing here, I'm going to abbreviate, would be J and 202. The second pairing would be C and 142. The third one would be E and 138. And the last one would be S and 202. So, do any of the x's repeat? They do not, which then means it is a function. Alright, remember, the y's can repeat. That is not important. The x's cannot. And then again, this is going to go back to domain and to range. With So with the domain, it says find the domain and the range of each relation. So you're just going to write it. So my domain then, here, let me actually erase this little circle. My domain then, it's the set of all x values. So I'm going to say 4, 6, 2. And actually when we write these, we typically write it in numerical order. So it would be 2, 4, 6. Okay? And then my range would be 0, 0, 0. And when we actually write it in the range, if a number repeats, you just write it one time. So my range is 0, my domain is 2, 4, 6. So my question is this a relation? Is it a function? Excuse me, is the relation a function? And when I look at this, obviously we can tell it is because the domain does not repeat. So this is a relation. Okay. Now we go to example number 3, and this is kind of a little bit of a repeat of the other day. So let's go ahead and look at this. I've got f of x, 2x plus 1, and I tell you that the domain is 0, 3, 5. So I want you to find the range, okay? So my range is going to go down here. All I do is I plug these values in for x. I get 2 times 0 plus 1. This is going to be 0 plus 1, which means f of 0 is 1. And then I do f of 3. That's 2 times 3 plus 1. That's 6 plus 1. And you get f of 3 equals 7. And then you've got f of 5 equals 2 times 5 plus 1. This is 10 plus 1, which means f of 5 is 11. And here is my range now. Okay, so a little bit of a repeat of the other night on this one, but it's an important problem to have and to do, so we need to be concerned with that. I hope you guys have a great night. Please remember, be on your best behavior for the sub the next 2 days, and come to class tomorrow prepared to work. I will see you on Monday.